In this video we're going to look at a maths problem that featured in one of the Maths Olympiads. So question 1. A and B are integers where ab plus 1 divides a squared plus b squared. Show that a squared plus b squared divided by ab plus 1 is the square of an integer. So step 1. Let a squared plus b squared over ab plus 1 equal to k, and we're going to show that k is the square of an integer. So multiply across by ab plus 1, we get a squared plus b squared equals ab plus 1 times k, which means a squared plus b squared equals abk plus k. If we compare the left hand side and the right hand side terms, we get a squared equals abk and b squared equals k. Now I could have equally written a squared equal to k and b squared equal to abk as well. But a and b are invariant here. What I mean by that is if we swap a and b, it doesn't change the answer. So we could write that as b squared plus a squared over ba plus 1. Because a and b are positive integers, that will not change the answer. That will still be equal to k. You can try it yourself. So I've just decided to let a squared equal abk in this case. And we can simplify that. If we divide across by a, we get a is equal to bk. This expression divided by a on each side, a equals bk. And then of course b squared is still equal to k. We can't really simplify that, nor would we want to, because that is basically the answer. So that means that a is equal to b times b squared. I'm substituting b squared equal to k into this a equals bk expression, which means that a is equal to b cubed, and of course b squared is still equal to k. That hasn't changed. And that is basically the solution, guys. That means that k is the square of an integer, the integer being b in this case, so k equals b squared. But it will only work if a equals b cubed. That's the other constraint or condition. And equally we could have said that b is equal to a cubed. As I say, b and a are invariant. If we swap them around, it will still work. That is the solution. Now I'm not going to prove it in any great detail. I'm not going to go into any sort of gory details, but let's have a quick example to show it in action. So pick any integers a and b where a is equal to b cubed, and you can try it yourself with as many integers as you like and it will work. So I'm just going to do a quick example to demonstrate that. Okay, so for the example, I'm going to let a equal 8 and b equal 2. So a is equal to b cubed. And we plug those values into the original equation. We get a squared plus b squared is equal to 64 plus 4. I'm not going to multiply it all out. You can do it yourself. And then ab plus 1, that's equal to 16 plus 1. We're using a and b equal to 8 and 2, remember? And that comes out to be 68 over 17, which equals 4. And 4 is equal to 2 squared, which equals b squared, since b equals 2. And that didn't happen by an accident. That happened, as we've already proved with the algebra that I did earlier, that when a equals b cubed and b squared equals k, this thing works. Likewise, b could equal a cubed because they're invariant, as we proved earlier as well. So guys, you can plug in any values you like as long as a equals b cubed or b equals a cubed, and it will always work. Okay, so thanks for watching the video. Hope you enjoyed it. Please like, share and subscribe. I'll see you on the next video.